Recently, I discovered the Kernel Memory library for .NET Code. Kernel Memory is an open source library that allows you to index and search documents of various types, including Markdown, text files, documents in Word, PowerPoint, and Excel, PDFs, images, and more. And it lets you bring your own models and bring your own vector store to index them. So this lets you use AI to index any document you have that you want to get into a searchable format for RAG, or retrieval augmented generation. And it allows you to use whatever models you want to work with, including those on OpenAI or maybe an Ollama model that you have on network. Now, the thing I really love about this is that this now lets me use on-device capabilities to analyze documents, to index them, and then search them. And not only can I search them to get relevant results for what I'm searching for, but I can also use question answering to ask an LLM questions about things from my knowledge base, and it's able to provide a nice answer. So the code for this is super simple. We're going to dive into it here. Here I am in Visual Studio 2022, and I have Kernel Memory installed, and I also have Spectre Console installed. I'm using a little console application. We're just going to take a look at this in a nice and pretty way. So I have some handy-dandy little things at the beginning just to use kernel memory and to write out a header at the top of the application because I like things that look nice. And then I'm going in and I'm loading up my settings. My settings have information about all my various models and things like that. So if I open up my app settings, I see I have an OpenAI endpoint and an OpenAI key. I've set these to their actual values inside of my environment settings. Then I have a text model name. This is the LLM I'm using to ask questions of it. And then the main one I'm using is the embedding model. The embedding model is what goes in and it looks at the documents and the queries that the user answers, and it uses that to index them inside of a vector store. So I have these stored inside of an object, which I then load up. And once I have that, now it's time to set up my kernel memory instance. So in this demo, I'm going to be using OpenAI, hosted actually on an endpoint that we use with Leading Edge where I work. But I'm using OpenAI. I could just as well be using anything else. But I'm telling it, hey, here's my API key for OpenAI, here's my endpoint, here's the model and the other model I want to use. And then I just give it my configuration. And I tell it to build. Now, by default, this is going to be using the volatile in-memory vector store. This is not what you want to use for production, but it's really great for quick demos like this, or demoing at a workshop or something like that. But I could connect to Redis or Quadrant or whatever else I want to do. Azure AI Search is an option as well. There's so many different things you can connect to, both on the AI models and on the vector stores. In addition to that, you can customize a whole lot more than what we're doing here, but I'm just going to start us as simple as possible here. So once that's done, I'm going to go down and I'm going to start actually importing some documents. And I can have three different ways I'm doing this here. So the first thing I'm doing is I'm doing import text, and I'm actually giving it just some string that I want to index as a fact. This could be a string as long as you want it to be, but here I'm just giving it a simple sentence. I'm doing that again on the next line, and on this line I'm actually giving it an ID of my document, I believe. Well, I could be. So I can be giving it an ID of sample -ID. It does not like spaces in the ID names, just FYI. Found that one out the hard way. So that's the first thing you can do, is you can just give it some string and it will index that for you. The other thing you could do is you can go in and you can import a document. This is where you're giving it a file that exists on disk or somewhere you can access it, and it's going to actually index that locally for you, and it's going to put it into your vector store so you can access it later on. So this is where you're going to be using your Markdown files, your Excel sheets, your Word documents, your PDFs, things like that. And the last thing you can do is you can actually do web scraping. And the web scraping is where it goes off, it fetches your HTML from your web page, and it's sort of analyzing the contents of your web page. I haven't played too much with this. It has a built-in web scraper, but you can also substitute your own if you want to, which is really neat. So really nice ways of sort of indexing information available to you. And if you want to, you can actually go in and you can tag things as well. And this is really cool, because what tagging lets you do is it lets you query later on and saying, hey, I only want things with these tags in it. That's really handy if you have tags for different customers or users or organizations, and you don't want to include things that belong to other customers, for example, or you only want to show things that are appropriate to your security role. So very common use cases, and we support those by tags and indexes and filters. So lots of capabilities built into kernel memory for that. Next thing we do is we are going to be using the search API. So there's two different ways of indexing information on kernel memory. You can use search or you can use ask. Search is where we're just going to be looking at, hey, what are my most relevant results from an embedding comparison? And asking is where you're actually involving an LLM and saying, hey, find the most relevant results and then try to answer the question I asked you. So I'm going to say, hey, I want to search your results. Here's the string that I'm searching for. And then it gives you back a search result, which has a results collection with citations in it. And each citation is going to be a document that it matched on. And those citations are going to have one or more partitions inside of them that matched on that. And each of those individual partitions within a citation is going to have a relevancy score from 0 to 1, with 1 being 100%. 100%, you're going to see that if you have like an exact string match for the exact thing that you're searching for. So pretty cool stuff. You can get access to the entire text of that. You can get access to the document ID. You can get access to the tags, things like that. So let's see this in action real quick before we move on. So here is our nice little ANSI console, Spectre console Figlet header. Now it's asking me, what do I want to search for? Well, I have a lot of things in here on kernel memory. So tell me about kernel memory. And it searched my vector store, and it found these 6 results were the most relevant things. And you can see there's a score associated with each one of them. We also see the kernel memory web page has 2 results. So there's 2 partitions here that were relevant. One of them is slightly more relevant than the others. So that helps you understand a little bit more about kind of how this is working, what's going on. You have things you can do, like you can filter the minimum relevancy score and things like that. So that's pretty cool. Now the next thing we can do is we can actually ask it questions. So let's go to the code for that, because the code is actually even simpler. Code for that is really simple, where we're just calling ask async. We're giving it a string that represents the question that we're trying to ask, and then we're getting back a memory answer, which is going to include a response for us. So when I go back in here, and I say I want to ask it, how does kernel memory compare to semantic kernel? And it's going to do its search, and then it's going to take the results of that as a RAG source, and it's going to feed it to the large language model I gave it. And then it's going to respond to me with that. I'm not using streaming responses or anything like that. So it does take a little bit more time for this, but we should get a result here pretty quickly. It'll tell us a little bit more about the answer to that. And you can see here it spat out a response that is in part based on the data that I provided to it. So we see it's giving us a comparison based on the data it had on semantic kernel and the data in kernel memory's documentation on semantic kernel, and the information on kernel memory itself in its own documentation, which I've included somewhat here for this. My Cliff Notes answer of this is that semantic kernel is a really good AI orchestration solution. It's really, really, really relevant for that. Kernel memory, on the other hand, is really good at indexing things and acting as a RAG data source when you have that need. And they can actually work together, so you can use kernel memory basically as a tool or series of tools that plug into semantic kernel as a plugin. And in fact, they actually ship a plugin out of the box that lets you integrate kernel memory into semantic kernel, basically replacing the vector store layer there, which is really cool. Now, you can deploy kernel memory serverless like we're doing here. There's also a Docker container for kernel memory, and they have a service-based mode as well. I'm still doing some more work with kernel memory. I'm looking into it. I'm really enjoying it so far. It's a very fulfilling library to work with, and I'm excited that I was able to put it into the new book that I'm writing that should come out later on in 2025. So stay tuned on that. Now, I have a lot of really interesting things I want to do with this. For example, I want to have it look over my Obsidian knowledge vaults, or maybe some collection of old blog posts, or even things like using role-playing game source books that I own legally. Well, I can use that locally on my own network to help fuel my AI-powered Dungeon Master project that I've been working on off and on as I can. And so I'm really excited about this, because this lets me use my own on-network Ollama models and my own on-network vector stores, and it lets me do new things there. Additionally, this is really easy to demo to people because it has the really good built-in vector store, the in-memory one. Now, you still have to provide some sort of a large language model. Typically, you'll care more about your embedding model, but if you want to use the ask endpoint, then you should also give it the text model as well. But very, very promising library that's still in development, and it's still growing, and Microsoft has really applied a lot of the lessons they'd learned from semantic kernel and other projects and really helped this thing shine even more. And I'm really excited to work with it.